In this week's lab, you will determine the relative acidity of a number of different substances. So some of these are strong acids, some of these are weak acids, and some of these are everyday items that are found in households, such as carbonated water or tap water. So you'll be measuring the pH of these using a pH meter, and also you will measure the pH of these substances using different types of dyes. Some of these dyes are methyl orange, thymol blue, and bromothymol blue. That's one of a selection of indicators that you will use. And then a third way that you will measure the pH is with these pH strips. So these pH strips are sensitive to a specific range of the pH. So what I'm holding in my hand are pH strips that are sensitive from pHs 10 to 13. Here we have pH strips that are sensitive from 5 to 9. Look at the pH ranges when you determine what strip you want to use. Here the pH strips are sensitive to pHs from 3 to 6. We also have pHs that are really in the acidic range, pH papers that is sensitive to pHs in the range of 0.0, that's very acidic, to 2.5. So you'll measure these substances, their pHs, using the pH meter. Then you can measure the substances using pH strips. Make sure you have to deduce or decide which is the right pH strip for the pH range that you're going to select. And then you can determine the pH using these indicators. Okay, these indicators are just dyes that are sensitive to acidic or basic pHs. When you add these indicators, all you really need to do is add 2 drops at maximum. So you want to conserve your indicators because adding too much just simply is a waste. So here's a small selection of chemicals that you'll be measuring the pH of. Okay, here is sodium dihydrogen phosphate. Here is acetic acid. Here is 1 molar hydrochloric acid. Okay, that's a strong acid. That's one of our 6 strong acids that we should memorize. Here is phosphoric acid. Okay, notice the difference between this and this. All right. The difference is that this has a proton. This one has given off a proton and has the sodium counter ion. And what's also interesting in this lab is you're going to be measuring the pHs of metal nitrates, aluminum nitrate, zinc nitrate, and not shown here is ammonium nitrate. So believe it or not, these are also acidic, which means they can give off a proton. Some of the other household items that you will measure the pH of, according to your table, deionized water, tap water, carbonated water. So you'll have a whole spectrum of chemicals that you'll measure the pH of, primarily using 3 techniques. Once again, it's the pH meter, using the pH strips. So this is where you and your partner will have to decide which pH strip and which range you'll want to use. And then finally, using these indicator dyes. So when you use your pH meter to measure the pHs of the substances, the first thing you'll do is click under Chemistry Labs. And when you click under that folder, you should double click under the pH meter. And so my pH meter is still sitting in the electrode buffer. So what we want to do is get this pH electrode out. And you want to never dry your pH electrode. Letting it sitting out for a couple of minutes by itself is okay, but you never want to let it for several hours or even several minutes. Let it hang like this. Always keep it wet or stored in some sort of electrode buffer. One quick healthy swipe of the electrode. Here you can see the pH electrode. That is going to measure your pH. And what I have here are a series of calibration buffers. So this is known to be a pH 4 solution. This is known to be a pH 7 solution. And this is known to be a pH 10 solution. So what I'd like to do is usually just instruct or calibrate the pH meter to realize this is what a pH 4 measurement looks like. This is what a pH 7 measurement looks like. This is what a pH 10 measurement looks like before I sort of put in my actual sample. So usually I do a 2-point buffer calibration, one at pH 4 and one at pH 10, so that it's just priming or instructing the pH meter that whatever sample I put in is going to be relative to something that it knows it's 4 or relative to something that it knows it's pH 10. All right, here's my pH 4 calibration buffer. I'm going to soak it in there. And you may want to actually put the calibration buffer in a separate beaker, a secondary container. I've inserted the pH electrode directly into the primary container. Probably good science would tell us to put this into a secondary container, but that's okay because I know, and I've stored these already in, I know these are going to be pH calibrated buffers meant for calibrating pH meters. So put the pH electrode in. Let's go back to our computer. And under experiment, you're going to go all the way down to calibrate. Instrument you want to calibrate is the GoLink pH meter. I will click under calibrate now. It says enter value in data units. So if you look back here, this is a pH 4 substance. The manufacturer has said this is pH 4, so I want to instruct the computer that what the pH meter is sensing is something that is 4. So let's go back to our calibration setting. Reading 1, enter value in data units. I'm going to put 4.00. I will hit keep. One thing you should notice here, notice that voltage. That voltage should actually change. If that voltage is staying the same or not doing anything, then it's not really measuring any potential because the electrode in the pH meter is actually measuring a potential, a voltage difference between what's inside the glass bulb and the solution. So keep an eye out for this voltage setting. All right, so now I've calibrated my first reading. So now let us get this into my pH 10 solution. So just a quick swipe after you dab it with some DI water. One healthy swipe or maybe a couple is good. And now let's put it into our pH 10. So we're going to calibrate this with pH 4 and pH 10. So let's put that in here. Let's go back to our computer. Notice my voltage. It's changed. Previously it was at 2.5 or something. Now it's gone down. So it's measuring a voltage or a potential. I will go to reading number 2 and put in my value. I've stored this into a pH 10 calibration buffer according to the manufacturer. So I'm going to tell the instrument that what I put it in was a solution of pH 10, so 10.00. Hit or click on keep, and now you're done. Before you do that, always wash it off. Wash the electrode, and I can use the same CHEM wipe, just use the dry part, and one healthy swipe. Now you've calibrated your pH meter. You can go ahead and put this into your 11 or so samples that you'll have to measure the pH in. Once you've determined your pH using the pH meter as well as your pH strips, we have narrow pH strips and we have the wide range pH strips. From the wide range, you can go and narrow it down to the narrow pH strips that I've talked to you about in the earlier part of this video. A third way to measure pH are through these indicators. So we have 4 indicators here. It will be your job to determine which indicator would be best suited to determine the pH. Well, how do you determine that? So for a particular substance, you have the best type of indicator. You do not want to mix indicators. One substance or one chemical is going to get one indicator. So what's the best indicator to use? Well, look at the pH range where each of the indicators is functional at. So the most responsive indicator will be given by the most apparent color change. So you'll want to use thymol blue for a substance where the pH is from 1.2 to 2.8, so you would expect that indicator to be orange. If your pH of the acid that you're testing is between 2.8 and 8, then you want to go with the indicator thymol blue. It's going to be yellow in that range, but I would argue that's not a good choice. Why would I argue that it's not a good choice? It's probably not a good choice because you don't know what pH your substance actually is, because your substance can be pH 3, it could be pH 7.5, it could be pH 5, it could be pH 6. So there's a real wide range here in thymol blue. Probably the best way to use thymol blue is if you know that your pH is between 1.2 and 2.8. And then you can use your pH meter, you can use your pH strips, and with information combined with this, you get a narrow range. So the concept of picking the best indicator really is looking at which pH region the indicator is most sensitive at. If you have bromothymol blue and add 2 drops of it to your unknown solution and you get yellow, you really have no way of knowing whether your pH is 0, 1, 2, 3, 4, 5, or 6 of that substance. Well, if you know beforehand that your pH of the solution, the unknown that you're testing, is between 6 and 7.6, and you add bromothymol blue to it, you should expect green or some sort of light green color. So using these indicators requires a little bit of backhand knowledge. Or you can put the indicator in and see what color you get. If you're lucky and you get a green, then you know that you're within this pH range. But if you add bromothymol blue to your unknown chemical, the solution in which you want to find your pH, and you get yellow or you get blue, then the situation occurs where you may have to choose another or better indicator for your sample. So 3 different types of measurements for pHs. Like I said before, the pH meter, these pH strips, we have the wide range pH strips, we have the narrow range pH strips, and also the third method would be using these indicators. Make sure you choose the right indicator. If you put one indicator in and you get something that's very broad, you probably have chosen the wrong indicator. So take more of that sample and put in the right indicator so that you get a more narrow range of the pH for that particular sample. So that's today's lab. Minimize waste as always and have a fun and enjoyable lab.